Welcome back, everyone. Today is the last of the shortcuts that we are going to be learning to prove triangles are congruent. In today's lesson, we're going to focus on angle, side, angle. One thing I would like to point out, just like we saw in our side angle side, that the side in this case needs to be between the two angles. It's the included side. So the included side is the side located between two consecutive angles of a polygon. In the figure below, it should have line segment AC is the included side between angle A and angle C. So you can see that angle C and angle A, they have that line segment as part of their angles. So again, it needs to be the line that's connecting them. Okay, the next slide, we're going to go through some more examples. If two angles and the included side of one triangle are congruent to two sides and the other included side, then the triangles are congruent. So again, we're looking for angle, side, angle. So in this case, we have this angle here is going to be corresponding to that angle, and then we have this angle here. And we need the side that connects them. So it would be this here side. So since that is true, we can use the shortcut of side angle side. All right, we're going to go through a few proofs here again. Hopefully as we're working through these, you can kind of catch some of the tricks as we work through them. All right, so the first thing we want to note is that they tell us that this is given. So here, that is all part of what we already know, so we can just write given. When we go to look at our diagram, it's important that we also make any markings or notation where we would have any congruency or anything that we might otherwise know. So it tells us that L is the midpoint of WE. So here we have WE here. So since that is true, then we can make the mark that these two are congruent. So somewhere in our proof, we know that there's going to be a statement that says this, LE. So we can kind of see where that is already. Well, that's down here. Well, that's definition of a midpoint then. So let's go through and see if we can find out anything else. It tells us that lines WE, so I'm going to make some markings here, WR, that that line segment right there, and ED, at this line segment, that those are parallel. And like I mentioned in previous lessons, when that is true, we can look for angle relationships. So here's a transversal. Now let's see what this statement says here. Well, if you look at that statement, it's saying something about angle R, so this angle here, R, L, W, okay? And then they are saying something about E, L, D, okay? Well, actually, I didn't need the fact that those are parallel lines then. All I need to know is this angle relationship. So again, when we have an angle relationship that looks like an X, these are considered vertical angles. So we say definition of vertical angles. All right, so let's see. We have this side already here, we know, and we have this side here. We have that these angles are congruent. In this case, we would maybe need to get the other angle, because we know that we're using angle side angle. So this is where we're going to use the parallel line part or strategy here. So I'm going to pick a different color here. So if this here is my angle and this here is my side, well, I would want this other angle because it's the one that connects them. So if I look in the other triangle here, I already know that this side right here is known to be congruent, and I know that this is the other angle. So I would need the side that connects them, which would be this side. So I have to look at this angle relationship was the midpoint. So we knew this and we knew this. And so if that's the case, then I would need to figure out this angle right here. And I would want to have this angle right here. Well, those two are related because of the fact that we have these parallel lines right here. So if I have this parallel line and this parallel line, then here's the transversal. So this angle that we're looking for right here has an angle relationship that has to do with the transversal, and that would be alternate interior angles. So it tells us that we just need to name the angle now. So we would say angle RWL is congruent to angle, see, we started at R, so we would have to start at D. So you get, say, DEL. Right, based on our drawings, we have that these are congruent because we have angle side angle. Alright, I think I have this figured out now. So let's look ahead at what we just found out. We found out that ADB was congruent to, we started at A, so start here, CBD, and we'll do the purple one now, and that is that angle ABD is congruent to angle BDC. Alright, well, we can see that right here, that is given. So our reasoning has to be that they are alternate interior angles. So they'll be the same for both of them. Alright, the next statement that they give us, that BD is BD, well, sure enough, that's the same line. And again, we've seen this before, that this is reflexive. Alright, so the last thing we need is this statement. So we're going to take what we wanted to prove, a triangle ABD is congruent to triangle CDE, and we have the angles and the line that includes them, therefore this is angle side angle.